All right, Algebra 1B students. Welcome to part 3 of our video talking about combinations and permutations, doing some more statistical things here. In our last video, we were looking at how many ways there are to arrange a certain number of things in a row, right? 9 baseball players or 8 swimmers or whatever it is. And in this video, we're going to extend that idea slightly. We're going to talk about arranging a certain number of things out of a bigger population, okay? Now, for example, what that might look like is a band has 7 new songs. So they've recorded 7 songs, and they want to put 5 of them on a CD. How many ways can they arrange 5 of the 7 songs so that you have this demo CD? It doesn't mean that you're arranging all 7, because we talked about that, right? 7 times 6 times 5 times 4 times 3 times 2 times 1, 7 factorial. It's not 7 factorial. It's actually a different formula, slightly different formula. It still involves n factorial, however. That factorial thing we talked about yesterday, where we're doing 8 times 6 times 5 times 4 times all that stuff. But we're going to divide it by basically how many things are being left out, factorial. So for example, if you want to take 8 things and arrange 2 of them, 2 of those 8 things, you do the 8 factorial on the top, and then on the bottom you do 8 minus 2, 8 take away 2, there's 6 left, you do 6 factorial on the bottom. Okay? Now this mathematics looks complicated. But I promise you, it's not as complicated as it looks, because when I do 8 factorial, that is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then on the bottom of the fraction, I have 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1. Notice that most of those numbers are actually exactly the same. The 6's can go away, the 5's can go away, the 4's can go away, the 3's can go away, the 2's and the 1's, what are you left with? 8 times 7, which is 56. Okay? So the mathematics here is not as hard as you may think, but you still may want a calculator for some of the bigger multiplication problems we have to do here. Now, let's look at this example together and deal with this formula, n factorial over parentheses n minus r factorial. Okay, remember n factorial is the number of things I have, so this band has 7 new songs, and now r is how many things I want to choose. That's 5, so the bottom of my fraction is going to be 7 take away 5 factorial, right? So the top again is 7 factorial, the bottom is going to be 7 take away 5 factorial. Now what is 7 take away 5? 7 take away 5 is 2, so the bottom is just going to be 2 factorial. Right, here's what that looks like. The top is 7 times 6 times 5 times 4 times 3 times 2 times 1. That's the top of the fraction. That's 7 factorial. The bottom of the fraction, 7 minus 5 is 2. 2 factorial is really just 2 times 1. That's it. 2 times 1, that's it. Done. So I now have this as my equation for how many different ways this band can create a 5-song demo CD. As I mentioned, a couple of these things can cancel out. The 2's can cancel out and the 1's can cancel out. All I have left then is 7 times 6 times 5 times 4 times 3, and then I'm done. I do that on my calculator, and I end up with 2,520 songs. Okay? CDs. 2,520 different arrangements of those songs. 7 times 6 times 5 times 4 times 3, because the 2 and the 1 got canceled out in my factorial equation. All right? I'd like you to try to apply that formula for a permutation to this as well. There are 6 students in a classroom where there are 8 desks. How many possible seating arrangements are there? So how many ways can you put 6 students into 8 desks? That means 8 permutation of 6. So it's 8 desks, 6 students. So 8 permutation of 6. Use your formula to figure out what that equals. Then come on back and I'll show you what you should have. top of the fraction we know is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. The bottom of the fraction is 8 minus 6 factorial, which again is just 2 times 1 because it's 2 factorial. And when I make a fraction out of this, I can cancel out the 2's, I can cancel out the 1's, and I'm just left with 8 times 7 times 6 times 5 times 4 times 3 times 2. Oh, sorry, just times 3, and we're done. So I'll do that on my calculator, 8 times 7 times 6 times 5 times 4 times 3, and it equals 20,160 different ways to put those 6 students into those seats. 20,160 ways to put those 6 students into those 8 seats. All right? If you have questions about this permutation formula, what the factorials do or anything of that nature, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.